Hello all, in this lesson we're going to be talking about point-slope form, our second of the three forms of linear equations. So the point-slope form of a linear equation is a linear equation of the form y minus y1 equals m times the quantity x minus x1. And in this form, we'll kind of list them as some characteristics, but m is the slope, and x1 comma x2 is a point on the line. So as the name kind of talks about, point-slope form tells us the slope and a point on the line. So that's kind of the important distinction about point-slope form. Let's look at a few examples. So point-slope form could look like y minus 8 equals 2/3 times the quantity x plus 4. That would be point-slope form. We could have y plus 3 equals negative 2 times x minus 5. All of those are good. Some that seem a little less obvious would be something like y equals 4 times the quantity x minus 2. And you might be thinking, well, there's no number right in that spot after the y like in the other ones. Well, it's kind of like an invisible minus 0 that we just didn't even include there. And similarly, we could have y minus 4 equals negative x. And you might be thinking a couple things. Well, there's not even parentheses on the other side. Well, you could interpret it as, okay, there is a negative 1 here, and we would have had a minus 0 over here. So that kind of just disappeared on us, but it's still in point-slope form. Some non-examples would be things like y equals 3x plus 5. Here, even though there's a 5 over there, you might think, try to argue it's kind of similar to the odd examples we had before. The 3 is not really being multiplied by, the 5, so there's no parentheses, so that would not be an example of point-slope form. Also, something like 2x plus y equals 7 would not be point-slope form. We'll talk about what that form is later. So, we're going to be asked often to create an equation in point-slope form given different information. So the first case we'll look at is when we're given a point and a slope. So it says write the linear equation in point-slope form with a slope of 3 that passes through the point 4, negative 1. So we are going to substitute for y1, x1, and m in our formula. So this would be x1 and y1, and this would be our m. The only thing that is a little bit counterintuitive is when we have to substitute a negative value for our point in for our equation. So let's do this in 2 steps. So I'll write the equation y minus y sub 1 equals m times x minus x sub 1. And again, we've kind of seen this happen throughout this unit, but the y1 and the x1, those are the placeholders for the point. The regular y and the regular x, those are the variables that we're really looking at. Okay, so we are substituting in 4, negative 1 as our point and the slope of 3. So the y value is negative 1, but the formula has a negative, so for just a half second I'm going to write y minus negative 1, and then that's equal to our slope of 3, and then x minus 4. Now we shouldn't leave it like this. We should always clean up double signs, so the point-slope form of this equation would be y plus 1 equals 3 times the quantity x minus 4. And yes, our formula up here had minus signs here, but if the point is negative, those will turn into positives for us. And that'll be an important thing to remember when we go to graph these in just a few minutes. So here's just a few more examples, different ways they could have been written. It's passing through 2, 8 with a slope of 4. So I'm going to write the formula y minus y1 equals m times the quantity x minus x1. And I'll do y minus 8 equals 4 times the quantity x minus 2. There's our point. Let's try another one. We have a slope of negative 3 and the point 5, negative 8. Y minus y1 equals m times x minus x1. So we have y plus 8. I think some of you are definitely capable of handling going right to the plus 8 since that was a minus a negative 8. Equals negative 3 times the quantity x minus 5. Lastly, we have an example with a negative x value, so we'll see that as well here. Start with our formula. So we have y minus 2 equals slope of 1/3 x plus 6. Terrific. Okay, 5, 6, and 7 are very simple. Well, we should definitely pause for number 6 because that will throw a few students off. So we'll do y minus y1 equals m times x minus x1, and we'll plug 2 in for our y. So y minus 2 equals, our slope is negative 1, and then the x value is 0. So x minus 0 is just x. So we don't even need to have the parentheses there. So that would be the form of the point slope equation for that point. Odd because we have a 0 for one of our x values. Okay, let's look at our second case when we're given 2 points. So write the linear equation in point slope form that passes through 2, 6 and negative 1, 12. So the first thing we must do is find the slope using our equation m equals y2 minus y1 over x2 minus x1. We should be very familiar with that as we were doing that for our slope-intercept form equations before, but now we must do it again. All right, so m equals y2 minus y1 over x2 minus x1. Sorry, I got to zoom out. I'm not making anyone dizzy here. All right, we've got on the top 12 minus 6 over negative 1 minus 2. All right, so that gives us that m is equal to 6 over negative 3, or m is equal to negative 2. Great, but then we still have to continue on to write the equation. Now, we have 2 points, and we're trying to write it in point slope form, which only has room for 1 point. So we just must pick 1 point. And we will get 2 possible equations. So that we can check our answers and be more clear in class, let's always pick the first point that is listed to us. That way we can always be looking at the same one. Yes, there is another equation for all of these that has the second point. So using the first point, we'll plug into y minus y1 equals m times x minus x1. We just found that our slope was negative 2, and this point is the point 2, 6. So we have y minus 6 equals negative 2 times the quantity x minus 2. And that's definitely the correct equation. For thoroughness, we will show the other equation. So it's got to go through negative 1, 12. So y minus 12 equals negative 2, that's still our slope, double checking, okay, times x plus 1. And you're like, well, how can there be 2 equations? Well, oddly enough, this equation and this equation both would be the exact same line, and we're going to talk about how we graph them in a second. It's really just having to do with we have the same slope here, and it's just starting at one point or another, they would end up passing through each other. So let's look at another example here. We've got the point negative 3, 1 and 1, 9. So we start with m equals y2 minus y1 over x2 minus x1. M equals 9 minus 1 over 1 minus negative 3. So our slope is 8 over 4, or 2. Now I'm going to go ahead and stick with this first point. Y minus y1 equals m times the quantity x minus x1. I'm going to plug in 1 for y, 2 for m, and a negative 3 for x, which makes that a plus 3. And that is the equation through that point, those 2 points in point slope form. Okay, now if we are given a graph, we're still looking for the linear equation, so we're going to find 2 points that land on grid lines, similar to how we would have done this in slope-intercept form. So it changed to red here so we can see one right there, and the next nice point I don't think is until the bottom corner there. All right, so we would be going down 2, and to the right 5. So we're going to find the slope by counting the rise and the run. And so in this case, our slope is -2/5. And then we just need to pick one point and substitute into our equation. So we can pick this point here that we started with on the y-axis. That's the point 0, -3. So we go y minus y1 equals m times x minus x1. And we have y plus 3 equals -2/5. And x minus 0 in this case is just x. So that would be our point-slope form of the equation for that graphed line. So very similar to other instances, so we just find our slope like we would have in slope-intercept form, we find a point, and we go ahead and write our equation. All right, well now let's consider if we are given words. We're going to find the slope, and remember it is a constant rate of change. Sorry, not quite enough room there. And we're going to identify the point. It might look like an example or the current status or just kind of like a moment in time. So here we'll look at the following example. Yanni has 6 hours to finish reading his novel before bed. He casually reads 45 pages every hour, and after 2 hours he is on page 105. What page will he be on after 6 hours? So we're given one moment in time here that after 2 hours he'll be on page 105, and we're also given a slope 45 every hour. So that's our m, and this is our point. So we will want to distinguish that in this case what is kind of our independent and dependent variable. Since we have time, that's definitely going to be our independent variable, so our x value. So this is going to be x and this is going to be y. So we basically are ready to plug all that information in. Y minus y1 equals m times x minus x1. So y minus 105 equals 45 times x minus 2. So that's the equation for Yanni's reading. Now if they ask what page will he be on after 6 hours, 6 is going to be our x value, so we would go y minus 105 equals 45 times 6 minus 2. So we've got y minus 105 equals 45 times 4. 45 times 4 is 180, so y minus 105 equals 180. We'd add 105 to both sides, and we would get y equals, oh, what did I do right there? I don't know what that says. Add 105 to both sides, so y would be equal to 295. So that's the page that Yanni is on after 6 hours. A little bit out of room here, but Yanni is on page 295 after 6 hours. Terrific. Okay, so then we have a whole bunch more examples of this in word problems, but let's go ahead and look when we're actually graphing an equation in point slope. First, we're going to plot the point that they give us in the equation. And remember, the signs are opposite of what they appear. What do I mean by that? We'll see in a second. So we're going to start at the point given and count by the rise and run using the slope. Okay, so let's actually look at an example here. So we see y minus 4 and plus 2. So we have to go backwards and think about what point would have been plugged in to create that. So remembering that our formula is y minus y1 equals m times x minus x1, and that the formula has minuses in there. So when we see a plus, that actually means that the point had to be negative to change this sign. So this positive 2 here for x means that there was a point of negative 2. the minus 4, even though it looks minus, that minus is just from the formula, so that y value is actually positive 4. And yes, we have a slope of 3. So we're going to go to this point, negative 2, 4 first. So negative 2 up 4, and that's where we start. Since our slope is 3, we're going to rise 1, 2, 3 over 1 for our first point. And if we want more, we can kind of follow that pattern backwards. And sometimes it's nice to have a few more points on there before we draw our line so that we can make sure we are continuing in a straight way the whole time. And so that would be our graph. So again, this point here was kind of the pivotal point that we saw in the equation, and then we just counted by the slope from there. So let's do at least one more example. Let's say even jump right to the slightly tricky example in 25. Now notice I don't see parentheses on this side, so we could almost imagine a parentheses minus 0 here, which would tell us that our point has an x value of 0, and the y value isn't negative 2, it's the opposite, it's positive 2. So 0, 2 is our initial coordinate. M is here as negative 2, so we go down 2 into the right one, down 2 into the right one, and we continue, and if we want, we can even go backwards, and oops, not right there though, backwards and make some points all the way up here, and then go ahead and connect that with a straight line. Sorry, I missed a couple points there, but that is the line through for that equation there. All right. So that is all the different ways we are going to be able to look and use the point slope form, both creating the equation and then graphing an equation if we are given one.